Welcome to my session. So let me introduce myself. So my name is Torsten Strauß. I'm a consultant, trainer, speaker, and working for a company which is BP. Yeah, that's me. I mean, maybe the most important one is my email address. And let's go ahead. So I guess I have only 3 quarters, which is a challenge. But let's see how far we can go. Okay. And I need to admit that I have a cold. Maybe my voice sounds a little bit strange. So yeah, I apologize for that, but yeah, nothing I can, or I have no chance to to make it better. Anyway, 1 second. Let me go to. I prepared a Markdown language or some kind of a document for me and for you. I will share the resources later on because there's a lot of things which we need to do in order to have a CICD pipeline for an Azure Data Factory. Finally, it works, and it works pretty well in a few projects already. Never ever experienced any problems, so I can say it's proven to work, let's say. Yeah? So what I prepared is I will use a lot of links here and a lot of windows. Tabs in Edge. Anyway, so this is my Azure DevOps repository, which is called ADF deployment. And we can see that we have some files and we have a specific folder structure. I will talk about the folder structure later on. Just want to give you a brief understanding about the overall environment. So we have an Azure DevOps repository for sure, because we need to have one when we want to run a CI/CD pipeline. The next thing, for sure, we need 3 Azure Data Factory instances, at least for the purpose of demonstration. I have one which is called development, one is called test, and one is called production. For sure, we can add more stages or reduce to 2. At least you should have one which is called development and one is production. So then I have 3 appropriate SQL databases just to make sure that we are pointing, or the Azure Data Factory instances can point to different SQL databases. I will show you later how it will work. So this is not very important, but now it's becoming a little bit more complicated. So first of all, what we have to do is we have to go to the Git configuration of the Azure Data Factory instance. So you can see it here. This is my Azure Data Factory instance for sure. And when I launch the Azure Data Factory instance, whenever you set up the Azure Data Factory instance the very first time, you are asked for the Git configuration. And that is something which we need to do. And because we already have an Azure Data Factory, Azure DevOps repository created before, we can now go to the Git configuration, and we can now point to the existing Azure DevOps repository, which we created before. So there are a few things to be aware of. First of all, this is your Azure DevOps account. This is nothing else than the Azure DevOps project, or it's the organization. Then we have a project, right, which I called ADF deployment. Then we have a repository name, which has the same name as the project name, as you can see. The main collaboration branch is called main. And we have a publish branch, which is called ADF_publish, which is a default, which is not really required, but I guess, and at least last time I did it, the Git repository will always ask you about the publish branch. So again, we will not use the ADF_publish branch later on, but we have to enter value here. So the root folder is the root folder itself, and then we have the tenant. This is the tenant of your Azure Data Factory subscription. And then the most important one is you have to disable the publish from the Azure Data Factory Studio, because otherwise you will completely skip the CI/CD pipeline. So you can directly publish into the main branch and the CICD pipeline is not triggered. So that is something you want to avoid. So you want to ensure that whenever you do changes on your Azure Data Factory instance, in your development instance, that these changes only can happen in a dedicated feature branch. So, and from here you create a pull request to deploy your changes, and first of all, merge your changes into the main branch, and then you deploy the changes to test and finally production. So again, that is maybe the most important property you have to set, because this isn't the default. So let me go back to my document here. So everything is very well documented. I guess it's not very complicated when you know how it works and you have a documentation in place. So after setting up the Git repository and the Git configuration for the Azure Data Factory instance, and by the way, this is only required for the development instance, not for test and not for production, because you will not do any changes in test and production. You will always start from development, right? So there is no associated Git repository for test and production. So when you have everything in place, you need to create a service connection. So let me go to the service connection in Azure DevOps. So, and to simplify the demonstration, I use only one Azure resource group, which is definitely not best practice. That is the reason why I have also 3 service connections, but all of them are pointing to the same Azure resource group, which is called ADF deployment. Usually you have something which is called ADF deployment, which is your project name, and then something -dev, -test, and -prod. Yeah. So again, for simplification, I decided to have just one resource group. So therefore, the service connections have the same permission, because there's only one resource group available at that point in time, but for sure we can change this later on. So that is all you need to do, because you cannot run a CICD pipeline without a service connection. So let's go back. So we have 3 of them: dev, prod, and test. Good. So after setting up the service connection, we have to create an environment. Let me go to the environment. So an environment in our case, we are using the environment in Azure DevOps to make sure that for our so-called stages, one is production, the other one is test, we have an approver. So you can go, and you should create an approver for the production and for the test stage, because otherwise your CICD pipeline will deploy the code changes from development to test to production automatically without any interruption. So when you set up an approver, the CICD pipeline, so the CD, so the deployment phase of your CICD pipeline will stop before test and before production and ask the approver. And once the approver confirms that the changes can go to test and production, only then the CICD pipeline will do the changes in the appropriate stage. So that is definitely required. So currently it's just me, because I'm the only person in my Azure DevOps organization for now, which is okay. But usually you should have 1 for test and maybe 2 approvers for production. That is something which you can configure here. Okay, so now we have our service connection, we have our environment. Let's go back and see what we need to create next. It's a very good idea to use the so-called a key vault within the Azure portal, where you can save sensitive data, for example, passwords or whatever. So to be honest, what I prefer is not even to save the secrets within a key vault for an Azure Data Factory, but instead I save all the values which I need for the appropriate Azure Data Factory instance. So you can imagine, for example, that the connection to an Azure SQL database is different for your test and your production and for sure your development environment. It is not just about the password, it is also about the connection stream. Maybe you have, I don't know, a specific, I don't know, storage account or whatever. And again, these are, the storage account will be not the same which you will use in dev, test, and prod. This is not considered to be a secret, but it is a very, let's say, a very handy approach to make sure that you have one place, one central place for your Azure Data Factory instance to save all your configuration values. So for linked servers and so forth. So therefore, it's recommended to create a key vault within the Azure portal. Let's go to the key vault. We can see, for example, I have one here for dev and prod and test. Let me open just dev because prod and test has exactly the same secrets, but for sure different values for the secrets. Here I have only one secret to simplify the demonstration, which I call secret database connection. And when I go to the secret itself, we can see the value, and this value is definitely different. Let me copy this and bring it to Notepad. This value is different in dev, test, and prod for sure. Now here I'm referring to our development instance with a specific password, and for sure when I do the same test and prod, the value will be different. Okay, so now we have a key vault in place. Let's go further. So in order to connect the CICD pipeline with the secrets which we currently have in our key vault, we can and we have to create a library within Azure DevOps. So let's go to the libraries within Azure DevOps. So you can either decide to keep all the values within Azure DevOps, even the secrets. So they are even the, let's say, the libraries within Azure DevOps are, let's say, secured and protected. But again, I prefer to have a central place within the Azure portal because the key vaults can be shared across different projects, which is sometimes a little bit more handy, I would say. But anyway, so we need to have at least a library which can be either linked. So I do not want to do it because otherwise I need to change my my key vaults within the portal. And I think it is easier for you to understand what finally needs to go to the library. So we can see that we have a data factory location, which is a location of my Azure Data Factory for sure, for the appropriate one, because we are talking about the development. And we have one for test and we have one production. Usually we have them in the same location, but maybe you decide to move the location later on. Then we have the Azure Data Factory name, which is ADF Inside SQL Server Development. And we have the resource group name. And again, I'm using just one resource group name, but in practice you will have different. Then we have the Azure Data Factory subscription ID, which is nothing else than my subscription. And we have something which I call on, which I name key vault base URL. That is something I will explain later. But for now, there is just another variable with the name of this. Okay, so these are the libraries, or the library which I created here is just visible for the development or in the development stage of the CICD pipeline, and therefore only visible for the Azure Data Factory instance development, right? And again, we need to have another one for test and another one for prod and maybe another one for pre-staging or whatever. So, so now we have our, let's say, environment-specific libraries, and we need to have another one, which I call library ADF deployment ADF, which is a global one. And the global environment describes the Azure DevOps, let's say, or the Git configuration, we can see that we need to name the artifact folder. When we go to, let me go to the files. Again, everything is very well documented in my document. Otherwise, it's a little bit hard to remember everything. So we can see that we are mostly referring to the structure of our Azure DevOps repository. So let's go back. So the artifact folder is called build and deploy. So this is my artifact folder. That means there's background noise here. That means within the build and deploy folder, we finally get the ARM template, because whenever you do some changes in your Azure Data Factory instance, finally, this is nothing else than a change in your ARM template, Azure Resource Manager template. And the ARM template, so whenever you build your changes, will go into this folder. So that is the artifact folder. Then we have something which is called the environment prefix. And you remember that we created an environment with the name of env ADF deployment ADF. And then we have something which is dev, and we have something which I call test, and something which I call prod. So that means when you have a proper naming convention in place, you can already rely on, or the other way around, you can derive the name of the appropriate environment by the prefix, because you know that when you want to refer to development, test, or production, you just need to add -dev, -test, -prod. So, because we will see that in our CICD pipeline, which we finally need to create, we are iterating through an array. And we don't have an array in CICD, but we have an object, but we can consider this to be an array. So we will see this later on. So then we have the package.json folder, and that is the same folder where the artifact folder, or where the artifact finally is located, which is in our folder build and deploy. Then we need a pool, an agent pool, which will do, or which is responsible for the build and the deployment. And maybe you have your own self-hosted agent, or as you can see, you can use the Microsoft hosted one, which is the Azure Pipelines pool name. Then we have the root folder of our Azure Data Factory repository, of our Azure DevOps repository, which is ADF. So this is what you need to do in order to make it run. So let me go back to my documentation. So again, everything is fully documented, and I think with the help of the document, you are able to set it up on your own. So now we have a global library available. We have 3 Azure DevOps libraries available, one per Azure Data Factory instance, dev, test, prod. We have a service connection, or we have 3 service connections available, and we configured we have done the Git configuration. So that's all we did so far. So now we need to create at least 4 files. One is called publish_config.json. Another one is called ARM template parameter definition JSON. Another one is called package.json, and the last one is called ADF build deploy, whatever your project name is, .yaml file. So I will tell you how we can do it. So having this structure in mind, and we already set up the folder in the appropriate way. So we need to create one file which is called publish_config.json. You can see it here, that this file is located in the root folder. You remember that we already, at several places, we already made Azure DevOps available and aware about the location of this file. And This is the only content the file has to have. So let me go into the repository itself. So we can see that this is a file. And within the file, or this is an empty file, you have to name it publish_config.json. And then you have to add publish branch adf -publish and so forth. That's all you need to do. Okay, the second one is you have to create an ARM template parameter definition JSON file. So in order to do this, and again, whenever you do changes in your Azure Data Factory instance, finally you are changing the ARM template. That's all you need to do. So this is the result. And how can we create something like this? Because I'm pretty sure no one of us wants to create a JSON file because it's pretty error prone. So let me go back to my documentation. So what we can do in order to create the JSON file automatically for an existing Azure Data Factory instance with already existing, let's say, pipelines or whatever, or with an empty one, it really doesn't matter. What you need to do is you need to go to your development Azure Data Factory instance, to the configuration or to the management of the ADF instance, to source control ARM template, and here you need to check include global parameters in ARM template. And when you now edit the configuration and you say, okay, it is finally, or this JSON file is finally pushed to your Azure DevOps repository automatically. The result is the file which I already shared with you. So because I'm running out of time, pretty sure I'm not able to show you later how this will work, but you can see that we have an equality sign for a lot of parameters here. And when you want to overwrite, and you remember in one of my library, there was, or in all three libraries, there was one variable which was called key vault base URL. So the idea is when you want to overwrite a specific parameter within your ARM template by a library value or variable, what you need to do is you just need to replace the equality sign with a dash. So I will show this. So let me go down, even though I need to scroll. I'm aware of it, but otherwise I'm not able to show this later. It's also very well documented here, I hope. So you can see what you need to do. When you want to overwrite a value, you have to go to the appropriate, let's say, property within the JSON format, JSON file, and replace the equality sign with a dash. So that means once you replaced, or once you change the equality sign, you can now inject the variable value from your library into your CICD pipeline. So that means finally the CICD pipeline will replace the value with a one which is received by the library. So let me go down, let me go up. Go here, I think here we go. Yeah, here we are. Okay, so now we have our JSON file in place. And what we need to do now is we need to create another file, as mentioned, which is called package.json. So this is a content. I don't know, it is there. I don't know why we need to create this. Don't ask me, but it is required. So when we go to our repository, here we can see there's a new file which is called package.json, and this is the content. Just paste whatever is there, whatever is documented into the empty file, and that's it. So, okay, so now it becomes a little bit more, let's say, complicated because, I mean, we just made the configuration and that's all. But now we need to create a CICD pipeline because this is nothing which is there from scratch. You have, and this is your personal, let's say, decision how to create your CICD pipeline. right? CICD pipelines can be very easy or they can be very complex. So I think or the other way around. In order to make sure that the CI/CD pipeline finally builds and deploys your changes to the appropriate stage, you have to use your library, your environment, and everything you set up. That was the idea of setting it up beforehand. So the CI/CD pipeline which I created looks like this. So we have a variable group here, and we are referring to the library, the global library, which we defined. You remember this was nothing about, or it was mostly about the Azure DevOps structure. Then we have something which I called keyword prefix. That means when we have a keyword in place and we have the proper naming convention in place, we can now refer to the keyword prefix, which is which is named like this, right? And then we have something, and maybe that is the most important one. That is something which I consider as an array. It is not an array, it's an object within CICD or YAML, but you can see how it works. We have two stages, test and prod, because the build and the deployment within your development instance always happens automatically. But again, we want to make sure that that there's a controlled way to publish your changes to the test and production environment. So, and therefore, I think it is a very handy approach. What you can do is you can create an array, you can call a test, you can call a test, you can call it production, and now you can iterate through the, let's say, through the objects within the array. So you can do this like this. For each, 1 second, I need to go down. Here, each target in parameter targets. Yeah? So this is a loop. It means for every object within the object, you are iterating. That means you don't need to write the same, in our case, deployment YAML template over and over. You can refer to an existing YAML template, which handles the deployment, and you just need to pass the appropriate parameters. And because you iterate through the objects, you can now inject the right variables into the YAML template, which I really like because now you don't need to double or even triple your code. So this is how it works. And for sure, I will share everything with you because otherwise I'm pretty sure it's a little bit hard to understand how it finally works, but just want to give you at least an idea of how it works, right? So then we have the other variables, which we already defined, right? And finally, what the CI/CD pipeline does, first of all, it will installed Node.js, and then it will create the YARN template, which is nothing else than the artifact. So whenever we build the Azure Data Factory instance, the artifact is the YARN template. And the YARN template is finally uploaded into an artifact feed within Azure Data Factory for, let's say, auditing purposes, at least for auditing purposes, or maybe you want to roll back your changes, then you can go to the artifact feed. And from there, it will download the artifact and will use the YARN template to deploy the changes, first of all, to test. It is waiting for the approver to approve the changes, and then it will deploy the changes to test and finally to production. That is how it works. And again, I will share everything with you. So that means finally our YAML pipeline looks like this. So very easy. I don't want to go into detail another time. That's it. So that means we have our CI/CD pipeline in place now. Let me go back to my documentation. Scroll down. And you know that whenever you, or not whenever, but very likely when you have an Azure Data Factory instance, you set up some triggers, schedule or whatever. So that means there is no guarantee that all pipelines are stopped whenever you deploy your code changes. Because, maybe you don't even know when your pipelines are running, or the developer can raise a pull request whenever he thinks it makes sense to raise a pull request. So therefore, we need to find a mechanism to, first of all, to stop all the triggers and to wait until the pipelines are stopped, because we cannot overwrite the ARM template in test when the pipeline is currently running. So otherwise, the CICD pipeline will fail and it will cause a lot of trouble. There is one PowerShell script which is available in the official GitHub repository from Microsoft. So you can see it here. Which we now can use in order to make sure that we, first of all, stop all our triggers. And later on, we can use the same PowerShell script when we deploy the changes to enable and to start the triggers again, right? So because it is very likely that you are working with more than, let's say, one Azure Data Factory environment, because it is very likely, it is recommended to save all these, let's say, global templates in a global repository. So therefore, what I did is I set up a complete different Azure Data Factory project. You can even create the repository a complete different organization if you like. It's up to you to decide. And here we can see that we have our, let's say, deployment YAML pipeline, or this is template to be precise, as I already mentioned. So this is the one which is iterated by the pipeline itself. And this is the PowerShell script, which stops and starts the triggers. So let's go back to my documentation. We go down, it's a lot of code. We go down, down, down. Okay, so again, so you remember that the CICD pipeline will call the deployment YAML template for test and production. So this is how the YAML template looks like. So it has a lot of parameters, as you can imagine. So, and these parameters, all the parameters are completely retrieved by either the key vault or finally by the Azure DevOps library itself. So that means you don't need to worry about anything anymore. You can even reuse the same CICD pipeline with just a few changes, as you remember, because you cannot, for example, I think the subscription, for example, is something which you cannot have in a library. So some of the values cannot be part of the library. But you can see that most of the variables are already part of the library. That means you either have to do no changes or just very, very few changes to reuse the same CI/CD pipeline for another and a complete different environment. So, but for sure you can use the same YAML template, which will deploy the changes. You can see how it works finally, right? It will receive all the parameters, will deploy the changes, and before deploying, it will, this is a little bit annoying, sorry for that. First of all, it will stop the triggers, it will do the ARM template deployment, and finally, it will do some cleanup, and it will start the triggers after the deployment finally was successful. Otherwise, the CI/CD pipeline will automatically roll back to the former valid version of the Azure Data Factory instance. So that means you cannot break anything. So as already mentioned, whenever you want to override some global parameters, what you need to do is you need to replace the equality sign with a dash. Okay, that's fine. And when you have everything set up, you have to go to your branch policies. Let me go to the branch policies here. And within the main branch, let's consider you decided for the name main branch. Let me go to the branch policies. So there's, I'm not in the right one, but I can use one of them, I'm pretty sure. Yeah, let's go with this one. A little bit lost, I have too many tabs open. Here we go. Yeah, here we go. So this is our main branch, and now you need to configure the branch policies. So first of all, in order to make sure that you cannot do any changes within the main branch directly, but instead you force the user to create a release branch, you have to check the first, let's say, property, which is require a minimum number of reviewers. Here we can define how many reviewers finally have to approve the pull request. This is not about the stage. This is about the pull request. That means the pull request is a one which is something like what is it, a peer review, and when all developers, or in our case, let's say 2 developers, finally approve your pull request, then your CICD pipeline will start. So what I need, it's the other way around. It's definitely recommended to have more than one peer review, but in my case, I'm the only developer in my organization. And for sure, it doesn't make sense to allow requesters to approve their own changes. When you have something like this, one, and you check this box, there's still a need for pull request, and there's still a need for a feature branch, but you can completely pass the idea of a pull request. So the next property or the next policy you should set is named check for link work item. So when you enable this one, you can now either decide for required or you can go with optional. Usually, when you do changes on your Azure Data Factory instance, there is a specific purpose. The purpose is described in your Azure DevOps board, because usually what you have is you have a sprint planning. Every 14 days or whatever, you have a sprint planning, and there is a commitment about the changes you have to do in order to achieve the feature. So that means usually there shouldn't be any work, there shouldn't be any changes on your Azure Data Factory instance without having a work item which describe the purpose and the aim of the changes you're going to do. So in order to make sure that you can now point to the work item, and you will see within the work item, within the Azure DevOps board, all your commits, the history of the changes, and even the pull requests directly in the Azure DevOps board, it is recommended to say the check for a link work item is required. So let me go to one of my work items here, because I don't know if everyone really understands what I'm talking about. I'm pretty sure that I have some, here we can see, to prepare the session, we can see there are already some pull requests, there are already some commits related to this work item. Again, usually there is no work without a proper work item description. So that is how it looks like. So, and finally, in order to make sure that you have a build validation, you have to set up your pipeline in the property or in the policy build validation. So here we can say the pipeline I want to use in order to validate my build is the one which I set up. So that means whenever I commit my changes, the CICD pipeline is automatically triggered, but only the CI phase of the CICD. That means only the build is validated. That means the pipeline will validate the YAML template, but it will not automatically execute the CD phase of your CI/CD pipeline, which means it will not automatically deploy the changes to test and production. Instead, you have to raise a pull request, because when you raise a pull request and someone approves your pull request, then the CI/CD pipeline is executed another time. Don't ask me why we have to go with another CI, because the CI is already there. I know we can do it. We can change the behavior, the standard behavior in the condition of the CI/CD YAML pipeline itself. But by default, the CI, the build phase, runs another time. And once the YAML template is finally created, after the pull request, the changes will be automatically deployed to test and production. That means there will be no change without a pull request, without a peer review, and without, for sure, a commit before. So that is how it looks like. I'm not, because I'm running out of time, but what I will do is I will go to one of my former executions. So first of all, okay, we can do something like this. So I don't want to execute the pipeline because it takes 4 or 5 minutes. Yeah, I don't have time. But this is my Azure Data Factory instance development. And first of all, when I want to do some changes in main, let's say I want to delete something. And first of all, I get the message failed to delete because of the branch policies. I'm not able to work in the main branch. In order to make changes, I need to create a new branch. And usually I create a branch based on the main, because main is usually the last version of the deployment branch, because main is a deployment branch. Call it, I don't know, delete pipeline. So it means I have an independent so-called feature branch where I can do my changes, and other developers can have their own feature branches to do their changes. So now I decide to go and delete that one. Perfect. This time it works. And from here, I can now go and I must create a pull request. So we can see how it works from the feature branch delete pipeline into main, the title. And here I need to add, and I should add some reviewers. Let's add Frank Geisler. And let's say, and you remember the branch policy, I'm now forced, because this was required, to link a work item to the pull request. We can even use both. It doesn't make sense, but that's okay. Now I can say create the review. Okay, that's okay. Let me delete him. I can say approve. There's one error, I'm aware of it, but I will show you one pipeline and one pull request which was successful. And finally, I can say set autocomplete in order to make sure that the feature branch will be deleted after the work is done and after the deployment is done, because then your feature is released. So that is how it works. And when we go to one of the existing pipelines, I have so many different here. This is how it finally works. This is the result of the pull requests which are created before. So we have our build, the build of the development, right? So the ARM template is finally uploaded to the artifact feed. And before, for sure, it was created successfully. So then let's go back to the Azure Data Factory. The deployment of the test environment was executed because I approved the stage. So usually you should see a button here which is approve, and the person who has a permission to approve the stage has now to approve to deploy the changes. Let's go to test. Here we can see we are downloading the artifact. We are stopping the triggers. We deploy the changes, and we start the trigger again. Sorry, as mentioned, I have the cold. Okay, so that means with the help of the CICD pipeline, we are able to have a controlled way to push all the changes we made in a dedicated feature branch in our development environment to the test environment after our pull request. We have a chance to roll back or the pipeline will automatically roll back when something is failing. But if we later on figured out that we, I don't know, by chance we deleted the pipeline, there's always a way to go back to the appropriate commit, to the appropriate artifact, and to restore the pipeline. And finally, you can see that all the changes will go to production. So that is how it works. I know it's a lot of stuff. I have just 3 quarters, which is okay. I will share the document when someone tells me where I can upload the resources.